So I've chosen one of the hardest related rates problems that I can find, and we're going to do it together. So let's read it to start with. A sink shaped like a circular cone with radius 30 centimeters and height 40 centimeters has a leaky drain. Water drains from the bottom of the sink at 1 milliliter per second. Meanwhile, water from the faucet fills the sink at 3 milliliters per second. How fast is the height of the water changing when the height is halfway to the top of the sink? That is 20 centimeters. Okay, so a lot of the times the hardest thing about these sorts of problems is just getting started. So when we're not sure how to start, one of the most important things we can do is draw a picture. So let's do that. So we'll have some sort of a cone shaped here. Its height will be 40 and its radius will be 30. Okay. Now, somewhere around here we're going to have some sort of, maybe some sort of water sort of filling up part of the sink, and it seems like this is increasing, and what we're trying to find is how fast is the height of the water changing. So okay, let's take away some of these numbers and put in letters. So why would we do that? Well, these numbers are, well, I guess these numbers are constant. Really, the place we want to put letters is what's changing. So that'll be like this height here. Maybe I can use the green. This height here, we'll call that H, and this radius here, we'll call that R. I can move H over here. So what we're trying to find now that we've done this is dH dt. And so this is the first sort of really important step in when it's particularly a rated relates problem, is we need to answer the question, what are we trying to find? And in this case, the answer is dH dt. So our answer is going to be something with the dH dt in it. The answer will go here. But knowing what we're trying to find will help us a lot when we're doing the equation, because it might help us from not plugging something in when we shouldn't. So, okay. So now that we know we're trying to find dH dt, we need some sort of an equation that has a dH dt in it. So let's take, well, what's an equation that has an H in it? We can talk about the volume, maybe the volume of the water. And so we're going to have V is going to be volume of a cone, 1/3 pi r squared times h. And maybe I'll make my pi a little bit nicer. But this right here is what the volume is going to be. And so why is the volume important? Well, if we look at the problem statement, we're talking about how many milliliters per second. That's volume per second. That's exactly dV dt. The change in volume over time. So what is the change in volume over time? Well, it's given us the problem. It's 3 milliliters is increasing, and then maybe minus 1 because there's 1 milliliter draining, so equals 2 milliliters per second. I won't worry, maybe I won't worry too much about units. So knowing dV dt, we want to try and find dH dt. How are we going to do that? Well, what we can do is we have this equation with both v's and h's in it, and we can just take the derivative. So let's take the derivative of this with respect to time. So to take the derivative, what we'll get is dV dt, and then we need to make sure we do the chain rule here. So we'll do 1/3 pi times hr squared. Well, wait, we have 2r times h dr dt plus, we got to do, we're doing the product rule with r squared and h, and then we need to do the chain rule because you have 2r, the dr dt comes out from the chain rule, and then we'll have r squared dh dt as the other half of the product rule with the chain rule giving us this dh dt, because we just had an h here. Okay, now that we've done that, we have an equation that we want. We have a value for dV dt. We want to find dH dt. So now all we need is a value for r, dr dt, and h. So then this is the last part, and this is the thing. Is so now we have, based on this equation here, we have a sort of roadmap of what we need to do. We need to find all of these things. So, and we can use the information we know from the problem. So let's use h. So h is, well, we know that from the problem. It's halfway to the top, or 20 centimeters. So h is 20. And, okay, what's next? So we need to find r, and we need to find dr dt. So if we look, we can draw, let's see, if we draw this triangle here, we know that this big triangle is 40, 30. So what we can use is we can use similar triangles, and this part will be h, this part will be r. If we use similar triangles, so if we use the idea of having similar triangles, because all of these triangles will have the same angles, right? You've got a right triangle with angles, and if you remember trigonometry, this would be some sort of a 3, 4, 5 triangle, but we don't even need to know about the hypotenuse. We just need to know about r and h. So what we can say is 30 over 40 equals r over h. And now we can just simplify. So maybe let's put h on the other side and cancel. So we have 3/4 times h equals r. Okay, so now that means r, which is 3/4 of h, will be 3/4 times 20 is 15. And then, okay, now the last thing we need to find is dr dt. So I think maybe a good idea would be to take the derivative of this. So we can have 3/4 dH dt equals dr dt. Now, okay, we're in a little bit of a predicament because we found dr dt, but it's actually in terms of dH dt. And that's the thing we were looking for. But so what's going to happen is we're going to put it in here, and eventually we'll be able to factor it out. So let's take all of this information and put it together. So what we have is dv dt, which is equal to 2, is equal to, if we go back, 1/3 pi times 2 times r times h, so I times 15 times dr dt, which is 3/4 dh dt, 3/4 dh dt, plus r squared, so r is 15 squared, 15 squared, also times dh dt. So now it's just a matter of doing a little bit of algebra. We can solve for dh dt, we can pull these guys out. So we'll have 2 equals 1/3 pi times dh dt times a bunch of this nonsense. I'm just going to copy it here. 15 times 3/4 plus 15 squared. And lastly, we can divide, maybe let's divide both sides by everything but this dh dt. So we'll get dh dt equals 2 over 1/3 pi 220 15 3/4 plus 15 squared. And so you'll notice I haven't simplified any of the numbers. I'll leave that to you to do on a calculator if you want to. But right here, this will be our answer. So we can draw a box around this. That's the change in height.